everybody. Today we will discuss problems from quarterfinal of US Physics Olympiad year 2009 USAPHO. There were 4 problems, and for that amount they were given 60 minutes. But before that, please subscribe. In that case, you will get all problems from US Olympia from years 2007 till today's date. So, problem number 1. There is an image of Formalhaut B, the first extrasolar planet to be observed directly by visible light obtained by the Hubble Space Telescope. The scale of the larger diagram is shown on the lower left. The 13 seconds refers to the angle in arc second, subtended by 100 astronomical units at the distance of Formalhaut. The scale of the inset can be determined by size of the small box. First question. A planet is in a circular orbit of radius r and the period t. Derive an expression for the mass of a star in terms of r, t, and the gravitational constant g. You may assume that the mass of the planet is much less than the mass of the star. Solution. Because mass of planet is much less than mass of star, so we can assume that our planet rotates around star in a circular orbit with radius r, and we have force of gravity from this star equal to this regular expression, g m planet multiplied by mass of star and divided by radius square. But from other hand, this force must be equal to force according to circular motion. That's this one, mass multiplied by v square over radius. Now let's write what is velocity, speed. Velocity equal to distance, which is 2 pi r over period, which is big T. And now we can insert this v in this formula and equalize these two formulas. So we have this expression. Now we can cancel mass of planet and finally find what is mass of star. This is the expression. As you can see, this is exactly the third Kepler law that applied to circular orbits. So it means that radius cubes of radius is proportional to period square. And this is how to count mass of any star in these circumstances. Second question, question B. From the image, estimate the mass of the star Formalhaut in solar masses. You may assume that the orbit of Formalhaut B is circular and ignore any errors associated with the fact that the plane of the image is not coincident with the plane of the orbit. Recall that the radius of the Earth's orbit around the Sun is 1 astronomical unit. You don't need to do an error analysis, but the number of significant digits in your answer would reflect the accuracy of your answer. Solution. First, we can use this formula to estimate what is the relation between mass of this star compared to mass of Sun. That will be this relation. where RB, that's the radius of this planet, RE, it's the radius of Earth, TE, that's the period of Earth, and TB, it's period of this planet. Let's count further. Now we have to estimate the radius of orbit of this planet, which is here. We can use this scale and count approximately that this radius equal approximately 110 astronomical units, which is a radius of Earth orbit. Now let's estimate what is the period of this rotation. Here in this scale box we have position of this planet during 2 years, and this is the original box. The scale is 1 to 10, so we can count that for 2 years it's moved about 1.4 astronomical units. And let's count from this data what is a period. It means that the speed of this planet equal approximately this expression. This is distance 1.4 astronomical units divided by 2 Earth years, which is 0.7. And now to find what is a total period for this planet, we need to divide this circumference of this orbit divided by this speed. So that will be, and now we can estimate what is the period of this planet using these formulas, and finally that's about 980 Earth years. Now we can put these numbers here and finally count what is this relation, which is about 1.4. So that's the solution for question B. Hello everybody. Today we will discuss problem number 2 from US Physics Olympiad year 2009, USAPHO Quarterfinal. So problem. A ball of mass m is thrown vertically upward with the speed of v0. The ball is subject to an air resistance force that is proportional to the velocity, F equal negative kV. The ball rises up to height of h and then returns to the starting point after some total time tf. The acceleration of free fall is g. Determine the following. A. An expression for the velocity as a function of time in terms of any or all of the constants. B. Sketch the graph of velocity versus time. On the sketch, indicate the time to rise to the highest point tr and the total time of flight tf. You do not need to find either tr or tf at this point, but your graph should reflect relative positions of both. C. Find the time to rise tr to the highest point h in terms of any or all of the constants. Solution. First, let's write the equation for motion in this condition, because we already know that force of resistance proportional to velocity. So this equation looks like this. If we have vertical up direction is positive, we have such equation that ma equal negative mg, that's force of gravity, minus kv, so that's the negative direction to velocity. Let's rewrite it in form of a differential equation. We have first derivative from velocity by time, Let's equal this expression as a function of velocity. It means that we can split variables and rewrite it in form of. Now we can do integral for both parts, and that will be answer. When we integrate from velocity v0 to some kind of velocity v, and the time is going from 0 to t. So after integration we have this expression, or velocity equals this expression. Now let's check what do we have here. When t is going to infinity, we have v is going to negative mg over k. That will be terminal speed, and we can call mg over k terminal speed, like this. V terminal equal mg over k, and in this case we can rewrite this equation as this one. So that's answer for question A. Now we can sketch the graph for velocity versus time. Let's say we take terminal speed, that's about 60 meters per second, and initial speed at 30 meters per second up. So for this condition we can draw this graph. This is our graph, velocity versus time. So here we have initial velocity about 30 meters per second, and terminal velocity is 60 seconds. Velocity is going to 0 when time is going to a little less than 3 seconds. Yes, that's correct. That's approximately answer for question B. And now we can estimate what is total time TF, just counting what is the area under the graph. So that will be this, and probably here we have, in this point we have point TF when it's reach height equals 0. And the last question, find the time of rise to the highest point h in terms of any of all constants. Let's do this. We have to solve this equation when v equals 0. And if we put here v equals 0, we will get answer like this. Tr equal v terminal over g multiplied by logarithm from 1 plus v0 over v terminal. And now we can find what is total height h. We just need to integrate this expression, and the integral will be from 0 to h, and here from 0 to tr. Let's do this. This is our calculation. We have height h equal integral from 0 to tr from this expression, which will give us this expression. But tr is known, is this one. So we can insert this tr here and calculate what is the final result. That will be this one. V terminal equal this one. And now let's see what happens if we have terminal speed is infinity. So when there are no resistance from air. In that case, we can represent logarithm in the form of for small this argument. That will be x minus x squared over 2. When we multiply this, we will get a regular expression v0 squared over 2g. So that's the total solution. everybody. Today we will discuss problem number 3 from US Physics Olympiad year 2009 USAPHO Quarterfinal. Problem number 3. A parallel plate capacitor is made of two square parallel plates of area A and separated by a distance d much less than square root from A. The capacitor is connected to a battery with a potential V and allowed to fully charge. The battery is then disconnected. A square metal conductor slab, also with area A but thickness d/2, is then fully inserted between the plates, so that it is always parallel to the plates. How much work has been done on the metal slab while it is being inserted? Solution. Easiest way to solve this problem probably just to go from a point of energy of electric field. Let's draw this picture. Suppose that this is our charged capacitor. It has area density charge sigma on its plate. On the right plate we have positive charge, on the left plate we have negative charge. So it means that the electric field will be equal sigma over epsilon 0 inside. And we can count what is total energy of this electric field using this formula. Epsilon 0 is square over 2, that's volume density of electric field. We multiply it by volume, and this is the result. Now let's insert our metal square conductor slab, and we have next picture. When we insert this metal slab, inside of this slab electric field is 0. It means that on the left side of this slab we have charge with the density sigma, and on the right side negative sigma. And still we have between this side and this side we have electric field is the same as before, and between third and fourth area we have the same electric field E, but no electric field between second and third plates. So it means that we can count what is the energy of this electric field, and that will be exactly twice less than initial energy. Now we can count what is this total energy if we know what is initial potential and the geometric sides of this capacitor. So we have electric field equal voltage divided by distance, and we can put it here. So that will be this expression. It's a regular expression for energy of capacitor. If we remember that epsilon 0 A over D, that's a capacitance. And now we can count what is total work done in this process. That will be this negative expression. Negative, it means that work was done is negative. It means that the capacitor pulled this slab inside and we work against this motion. So that's the solution. Hello. Today we will discuss problem number 4 from quarterfinal from US Physics Olympiad year 2009 USAPHO. So problem. A certain electric battery is not quite ideal. It can be thought of as a perfect cell with a constant output voltage V0 connected in series to a resistance R small, but there is no way to remove this internal resistance from the battery. The battery is connected to big N ideal light bulbs in parallel. The bulbs each have a fixed resistance big R, independent of the current through them. Questions. Question A. Derive an expression for the total power dissipated by the N bulbs in terms of small r, big R, and V0. Question B. It is observed that the configuration dissipates more total power through the bulbs when N equals 5 than it does for any other value of N. In terms of big R, what range of values is possible for small r? Solution. For the first question, we can do next procedure. We know that power equal current square multiplied by resistance through which this current is going. So that will be this expression. This is the power through N resistors R, and R over N, that's total resistance for N parallel connected resistors. Next thing is to count what is current. Current equal total voltage V0 divided by total resistance, which is small r plus big R over N. And after that we can input this current here and find solution for the first question. This is the result. Power equal V0 square multiplied by N big R divided by N small r plus big R squared. Question B. It is observed that the configuration dissipates more total power through the bulbs when N equals 5 than it does for any other values of N. In terms of R, what range of values is possible for R? Solution. We have this expression for power, and we know that for N equals 5, this value greater than when N equals 4 or N equals 6. So let's solve these numbers. So first we can solve this equation for this inequality when N equals 5 and here when N equals 4. We have this inequality. So we can first cancel R, make a square root from both parts and reverse it. So in that case we have this expression. So we have this inequality from this inequality. Now let's count what is a relation between small r and big R from this inequality. We have this inequality, and the last step is we can just multiply top and bottom by square root from 5 plus 2. In that case on the bottom we have 1, and on the top we have a square root from 20. So it means that small r less than 1 over root 20 big R. Let's count what happened when N equals 6. We have this inequality. We do the same procedures here, and this is the result. When we cancel big R, we do square root from both parts and we reverse them. We have this inequality. After that we have this inequality, and multiply bottom and top part by square root from 6 plus square root from 5. We will get this inequality. And the last step is to combine this and this. This is the result. So we have small r belong to this inequality. That's it. This is solution.